Hey everyone, in this video and the following videos, we're going to be looking at how we solve system of equations. So what exactly does this mean? You might be wondering. A system of equations, and what is a system? What does it mean to solve it? To solve a system of equations, first of all, we have to be given two equations. We look for the point, so the point xy that satisfies, keyword satisfies, both equations. Okay, so this word satisfies, what does that mean to satisfy an equation? So I can tell you, just an example here, the point -2, 3, it satisfies the following equation. So the equation is 3x plus y equals -3. So I tell you that this point satisfies this equation, and what that means is when I place x and y into this equation, this left side will equal the right side. So when I place -2 in, so 3, place -2 in for x, and place 3 in for y. Okay, so -6 plus 3. -6 plus 3 is -3. And we see that the two sides equal each other. So when a point satisfies an equation, that will happen. So if I were to plug in, 0, 3, and place those values in, it would not satisfy it because what I get on the left side would not equal what's on the right side. Okay, so to satisfy an equation just means that when placed in, both sides of the equation are the same, are equal to each other. So to solve a system, we look for one point that satisfies two equations, and you'll have these two equations given to you. And there are different methods of solving these problems. So to begin with, let's look at, there are three different possibilities. So these here, there are three possible situations. There are three possible situations when solving a system of equations. I did not even think about this. This word system is referring to a group of equations. So when I solve a system of equations, I'm finding a point that fits a group of equations. And at the beginning here, we're just dealing with two equations again. So our three possibilities are standard form, where both of them are in standard form. So recall standard form is when both our x and y are on the same side, whether left or right, they're on the same side. So then the other situation is when one equation's in standard form and the other is either y equals or x equals. So that's another situation that will require a completely different process to solve than this first situation. And then we have both, when both equations are in y equals form. So I have examples here. So as we're doing these problems, I encourage you to write these down, to have paper, whether it be graph paper or just your notebook paper, to write these examples down, to pause the video at any point, rewind at any point you need to, but really utilize this video to understand how we solve systems with the various situations, okay? In this lesson, we're going to be focusing on the situation where we have one equation in standard form and one in the y equals or x equals form. So when this is our situation, we use what's called the substitution method. So the substitution method, we have one standard form equation, one equation in y equals or x equals form. So how can this be applied? What does it mean to have the substitution method, and how does it only work for this setup? So let's find the point xy that satisfies the following systems. So let's use this example first. Y equals 2x, and then x plus y equals 9. So we're seeing we have an equation in y equals, an equation in standard form. So step one. So since we have y equals, okay, since that's what we're given, we are going to replace y in the standard form equation. We're going to replace y with 2x. Okay, that's not always going to be replacing it with 2x, it's going to be replacing it with whatever y equals. All right, and then we want to solve. So what this looks like, so I'm going to use it to the side here. So we have y equals 2x. I notice that this is y, so I'm going to place this into this position. So I'm replacing y, and instead of writing y, I'm going to write 2x. So notice what I did there. And yes, I'm putting parentheses around it. Parentheses just because if I had a number in front, I would need to multiply by that number. All right, so we do that. Now we just combine like terms. So we have an x and 2x on the same side of the equation. So we combine them, so that's just 3x, and then our 9 drops down. So with no symbol in between our 3 and x, that tells us that this is multiplication. So to remove multiplication, we have to divide. So when dividing 9 by 3, we get 3. So that's x. Now you might recognize we don't know what the y value is. Well, that's where step 2 comes in. So step 2, we substitute the found value into the initial equation. Now this initial equation in this problem is the y equals. Now it might be x equals, it just depends on what we have. And we solve for the other variable. So we have x equals 3. So our initial equation was y equals let me move this up here. So we have y equals 2x. So we now know x is 3. So I'm going to say 2. Instead of x, I'm going to say 3. So 2 times 3 equals 6. And there's no plus or minus piece that we're going to have to add to this or subtract to this. So this is our y. So we have our x, we have our y. So our solution to this system, our solution is 3, 6. So placing 3, 6 into each of these equations, we would find that it would satisfy both equations. Let's look at another. So let's say we have x equals 3y plus 1, and then 2x plus 4y equals 12. So like before, if you need to, you can rewind and watch it. But like before, we see that since we have x equals, I'm going to replace x with this group. Okay, so x is being replaced with this group. So instead of x, I'm going to write 3y plus 1. Replacing x with 3y plus 1, we see that we get this new equation. And we have this group, and we should notice and recognize that we need to distribute. So we get 6y, and then 2 times 1 is 2. Then we simplify. So 6 and 4 are on the same side of the equation, so they combine to 10y. Now 2 and 12, yes, we're going to combine them, but because they're on opposite sides of the equation, we should know by now that we subtract, and we get 10y equals 10. We divide by 10, we get y to be 1. Okay. Now with y equaling 1, to find the x value, we substitute it into the initial equation, which our initial equation in this problem is 3y plus 1. So x equals 3. We know y now is 1, and plus 1. So 3 times 1 is 3, and plus 1 is 4. So we have our x, we have our y, and we have our solution. So the solution to this system is, I don't know why I wrote x and y. Our solution is 4, 1. What's interesting is before we found x first. We found x first. In this problem, we found y first. And then it just comes back to type of equation we had to begin with. So continue this with an additional example. We're going to see more the fallbacks, the downsides of this method. So we see in this next example, let's look at the setup of, or the system of y equals 3x minus 4 and 4x plus 3y. So this is our third example, and by now I'm going to kind of just skip over the couple things I was saying before. So if you need to go back, do so and watch the first two examples. So we have this system. So having y equals I'm going to replace y with 3x minus 4, which would make my equation look like this. Okay, and then with this equation, we get 4x, we get plus 9x, and we get minus 12 once we distribute. X is on the same side, so we can combine them. So 13x minus 12. Dealing with our addition subtraction, that gives us 13x equals 13. So we divide by 13, we get x to be 1. So that's x. So now we find y. So let's find y now. So y equals 3 multiplied by x minus 4. Well, we know x is now 1, so 3 times 1 minus 4. 3 times 1 is 3, so 3 minus 4 is negative 1. And we have our answer. So our solution to this system is 1, negative 1. So talking about downsides, this substitution method is really good when our solution is given to us exactly how we need it. And what I mean by that is, if my equations were both in y equals, or if my equations were both in standard form, I could change an equation to fit this, but it's more work. There's another method for that situation. So let's look at one more example and see what we can end with. So let's say we have this example of x equals 2y minus 1, and then 3x minus 6y equals 4. So x equals 2y, and we have 3x minus 6y equals 4. So having x equals, I'm going to replace x with 2y minus 4, giving us, okay, so we distribute, giving us 6y minus 3, because 3 times negative 1 is negative 3. Subtract 6y. All right, and let's see, 6 minus 6, ooh, it's 0. They cancel, they go away. So we're left with negative 3. Negative 3 equals 4. It's interesting. So there's no x equals, there's no y equals. This is unique. This tells us that we have parallel lines, which from the previous video, if you haven't watched it yet, you'll find it in the graphing method video. This tells us that there's no solution to the system, that we will be unable to find a point that satisfies both equations. So what told me this again, that there's no solution, is that we substituted our x equals into the other equation, simplified, and got down to where we had one number equaling another number, and that tells us no solution. If it was 4 equals 4, if we got down and it was this one number equaling the same number, that tells us something different that we're going to see in future videos. But right here, with negative 3 equaling 4 and not being okay, this is no solution. There's no solution to this system. So this is the substitution method, taking a given equation and placing it into the standard form equation, simplifying and placing it back in and solving. Play this video as many times as you need to. I wish you the best of luck in practicing this skill in solving systems of equations.